Wave quantities. This animation shows two waves, red and green, traveling left in the same medium. Let's say each box is 1 centimeter wide. Because both waves are in the same medium, both waves have the same speed. Each wave consists of several particles. One of the particles, the one in the center, is colored white for reference. Do you see where the two white dots oscillate up and down with simple harmonic motion? Since each particle makes simple harmonic motion, each particle has an amplitude of motion, which we'll call A, capital A, a frequency of motion, lowercase f, and a period of motion, capital T. All the particles in the same wave have the same amplitude, frequency, and period. So we would say the wave itself has an amplitude A, frequency f, and period, capital T. Can you tell the amplitude of the red wave and the amplitude of the green wave? Remember, each box is 1 centimeter wide. The red wave has an amplitude of 5 centimeters, and the green has an amplitude of 3 centimeters. Amplitude is the maximum displacement from equilibrium. You have the equilibrium right here for the red wave, and then right here for the green wave. Which wave has the longer period? The period is the time it takes to complete one full up and down cycle. So the red wave has a period of 2 seconds, assuming the animation is playing at full speed in the video. Then the green wave has a period of 0.4 seconds. To calculate the period, we would have to start from one point and then calculate the time that it takes to get to the second point. So let's say we want to start when the white dot is at the peak. 1001, 1002. Yeah, we're not playing this animation at full speed. Based on this information, what's the frequency of each wave? So once you find your period, which is the time it takes for one complete cycle, this is a lot. Stop. However many seconds between that start and stop would be the period. And then the inverse of that number, 1 over that number, is going to be your frequency. And frequency is how often events happen, and period is how long it takes for the events to happen. The red wave's frequency would be 0.5 hertz, half a cycle every second, because 0.5 is the reciprocal of 2. The green wave's frequency is 2.5 hertz, because 2.5 hertz is the reciprocal of the period, which is 0.4. Each wave has a wavelength. This is the distance from one crest to the next crest. Wavelength is also the distance from one trough to the next trough. Wavelength is also the distance from one point of equilibrium to that same exact spot on the wave. So it would make one complete wave with one crest and one trough, but you could start at the midpoint. The symbol for wavelength is lambda, and the units for lambda are the meter. But when we're dealing with waves, a meter is really big, so a lot of times we use metric prefixes. You may want to brush up on those. Oh, right. The animation's now stopped. Can you estimate the wavelength in centimeters of the red wave and the green wave? You would just count up each of these boxes. The red wave has a wavelength of 20 centimeters and the green wave has a wavelength of 4 centimeters. Back to the animation. Here's an important concept. A wave travels one wavelength of distance during the time of its period. Oh, the wave's distance, d, equals lambda, when the time it travels, little t, equals the period. Remember the equation for velocity? Velocity is distance over time. Let's plug it in to what we just learned to find out the speed of the wave. V equals lambda over t. Because t and f are reciprocals, we can change v equals lambda over t into v equals lambda f. This is an important equation that relates 3 important wave quantities. We said the red wave's wavelength is 20 centimeters and the frequency was 0.5 hertz. So the red wave's speed is 20 centimeters per half of a hertz equals 10 centimeters per second. If that half of a hertz throws you off, write it down. The green speed's wavelength is 4 centimeters and its frequency is 2.5 hertz, so the speed is also 10 centimeters per second. Waves in the same medium have the same speed. If you're taking the AP exam, the formula chart does not write V equals lambda F, but instead writes the equation as lambda equals V over F. It's the same equation, so why do we write it differently? This is the exact same thing with A equals F over M. It's because lambda on the left is the dependent quantity, and V and F are on the right, and those quantities are totally independent of each other. The wave's speed is determined by properties of the medium carrying the wave. The wave's frequency is determined by whatever emitted the wave, whatever caused the disturbance in the first place. Once the medium determines the wave speed, and the emitter determines the frequency, the wavelength is set by the equation lambda equals V over F.